Hi students, in this video we will discuss about arrays. So we will see here introduction to arrays. First we will see the definition for an array. An array is collection of similar elements. An array is collection of similar elements, or we can call collection of elements of same data type or similar data type, or we can call collection of homogeneous elements. Collection of homogeneous elements is known as arrays. Here what we can do with arrays is, so with one name, that is with arrays, with one name we can store, with one name we can store any number of elements. That is, multiple elements can be stored using arrays. What is the advantage if we store multiple elements? Now before going to advantage of arrays, so let us see, before arrays, suppose if you want to store three numbers, suppose let us assume that you want to find greatest among three numbers. Can you tell me what is the logic? Declare three variables, read three numbers from the user, read a comma b comma c. Then to find greatest among three numbers, you need to write the logic if a greater than b and a greater than c. Then display the message a is big. Then else if b greater than c, then we will write it as b is big, printf b is big, else c is big. Okay, because if a and b are not big, remaining number is c. You can write. Suppose if you want to find greatest among 100 numbers, tell me how many variables we need to declare? 100 variables. Then read 100 variables from the user. Then you need to check the condition if first number greater than second and first greater than third, first greater than fourth, so on to first greater than 100, display first number is big. Then else if, then for the second number, if second number is greater than third, second greater than fourth, second greater than fifth, so on to 100 numbers, then second is big. Else if third greater than fourth, third greater than fifth, so on to. So in this way you need to write the condition for all the 100 numbers. So the size of the program will become complex. That is, before arrays were introduced, the comparison was complex. That is, the finding greatest element or smallest element was very difficult, because we need to use number of elements or number of variables we need to use. Then when arrays have been introduced, the main advantage of arrays is comparison will be simple. That is, finding the greatest element and smallest element was very easy. After introducing arrays, comparison is very simple, because the main advantage with arrays is with one name we can store multiple elements. So with one name we can store multiple elements. That is, for arrays, memory will be allocated continuously for all the elements of the array in this way. So here in this case I have taken the size of the array as 5. So memory will be allocated for 5 locations in this way continuously. So with one name we can store any number of elements. That is the main advantage with arrays, so that the comparison will be simple and easy. Now syntax for declaring an array. So first let me remove this part. Syntax for declaring an array. How to declare an array? So in order to declare an array, So we need to use here data type. So array can be of integer type or character type or float type or double type. Data type, array name of, mention the size. Example, int a of 5. So what happens here is, when you declare an array int a of 5 with the name a, memory will be allocated continuously for all the 5 locations. And each location here is identified with the help of index number. The 0, 1, 2, 3, 4 are called as index numbers. Index starts from 0 and ends at size minus 1. Index of the array starts from 0 and ends at size minus 1. Now each element is identified in this way. So a of, we use here square brackets. A of 0 represents first element. So value at first location. A of 1 represents value at second location. A of 2 represents value at third location. A of 3 represents value at fourth location. A of 4 represents value at fifth location. That is, index starts from 0 and ends at size minus 1. That is, if the size is 10, it ends at 9. If the size is 100, it ends at 99. So here the main advantage of arrays is this one. That is, comparison will be simple. That is, finding greatest and smallest element will be easy. Suppose here just we have declared an array int a of 5. We have not assigned any values. So by default these memory locations contains garbage values. By default these memory locations contains garbage values. So in order to display the elements of the array, we can use either loops, or you can display the elements or access the elements individually. Also you can access the elements. Now let us see one example for initializing and displaying the elements of the array with the help of index number. Here initializing an array int a of 10, 20, 30, 40, 50, or just I will not assign any values, int a of 5. Then I will display the elements of the array like this: print a of %d, 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 %d slash n. Then a of 0 represents first element here, a of 1 represents second element, a of 2 represents third element, then a of 3 represents fourth element, and a of 4 represents fifth element. If you display here, save your program, compile and run the program. So end with semicolon here, then compile and run your program. Here you can see the garbage values 0, 0, 33, 0, 0 it is displayed. So run once again it is by default it will display the garbage values. If you run this program, you may get different values. Those unknown values we call them as garbage values. Now initializing a two-dimensional array, initializing an array. So int a of 5 equal to, I am assigning some values 10, 20, 30, 40, 50. Then instead of using this single printf, for displaying the elements of array, generally we use loops. For I equal to 0, I less than 5, I plus plus, I plus plus. Printf %d slash n comma a of I comma slash n a of I. Here first time tell me what is the value of I? 0. As index of the array starts from 0, we are using 0. So 0 less than 5, s. A of 0 will be displayed onto the screen. What is a of 0? 10 will be displayed. Then I plus plus 1. Then 1 less than 5s, a of 1 will be displayed. What is a of 1? 20. Then a of 2, a of 3, a of 4 will be displayed onto the screen. When I value becomes 5, it comes out of the loop. Now let us check the execution of this program. Here you can see you need to declare the variable I, int I. Now save, compile and run the program. Here you can see the output 10, 20, 30, 40, 50. Suppose if you want to display even the index number onto the screen, a of %d equal to. Suppose if you want even the index number also, that is a of 0, a of 1 if you want. So here what happens here, at first %d I value will be displayed, that is a of 0, a of 1, a of 2, a of 3. Here value will be displayed at second %d. Now you can see the output for this program. 10, 20, 30, 40, 50. Now in this example what happened, the size of the array is 5 and we have initialized all the 5 elements. So first 10 is stored in first location, 20 in second, 30 in third, 40 in fourth and 50 in fifth location it has stored. Now let us assume that size of the array is 5 but I have initialized only 3 elements. What happens here? So if the size of the array is 5 but I have initialized only 3 elements. So tell me what happens. So their index numbers are 0, 1, 2, 3, 4. Tell me what happens in this case. So 10 will be stored in first location, 20 will be stored in second location, 30 will be stored in third location, and the remaining locations it will be initialized with zeros. So let us check that program. Save your program, compile and run the program. So 10, 20, 30, 0, 0. So those 3 elements are stored in first 3 locations and the remaining elements are initialized with zeros. Now suppose if you have, I have initialized only one element. Now tell me what happens. Save. So 10 will be stored in first location and the remaining elements are initialized with zeros. Now this is one case. Now in the second case, 10, 20, 30, 40, 50, 60, 70. What is the size of the array? 5. How many elements I am initializing here now? 7 elements I am initializing. Now tell me which 5 elements it will store. First 5 or last 5 or middle 5, because here we have only 5 locations. So which 5 elements it will store? Here we cannot initialize an array more than its size. If the size of the array is 5, you can initialize only 5 elements maximum. If you try to initialize more elements, it will generate an error message. So here if you try to initialize more elements, here in this case it is giving excess elements in an array initializer. So you cannot initialize an array, it is giving some warning message and it is trying to store only first 5 elements. Remaining elements it will discard in this case. So we cannot initialize an array. If you initialize, it gives some warning message. Compile your program, you can see the warning, excess elements in array initializer. You cannot initialize an array with more than its size. Then now suppose let us assume that if you want to store zeros in all the array elements, by default it contains garbage values we have seen. Now let me check that. So save your program. By default run your program. it contains garbage values. Now if you want to store zeros in all the locations, so what you need to do here is one element you initialize with a 0. All the elements are initialized with zeros. All the locations are initialized with zeros. At least one element should be initialized in arrays. Okay, ma? Now another important point, let me tell you. So here 10, 20, 30, you can give any values 10, 20, 30, 40, 50. Now how many bytes of memory this array occupies? Because here we are creating, when you call int a of 5 with the name a, memory will be allocated for 5 locations. Memory is allocated for 5 locations. So each location occupies how many bytes of memory? 4 bytes of memory here in this case. Each location occupies 4 bytes of memory. So 4 into 5, how many bytes it will occupy? 20 bytes of memory it will occupy. 4 into 5, 20 bytes. So if you want to see how many bytes it occupies, we have a operator called size of operator. So we can see here size of a equal to %d slash n comma size of a. So it will give you how many bytes of memory that this array will occupy. So here one integer occupies how many bytes of memory? 4 bytes. 4 into 5, 20 bytes of memory it occupies. This is initializing an array. Size of a equal to 20. Okay, so more examples we'll see in next video. Thank you for watching.